Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Wait, Where? By Not Very Neat. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have Kropke dots, where digits separated by a black dot are in a 1:2 ratio, and not all dots are necessarily given. So as an example, if this were say a 2, this would have to be 1 or 4 to maintain the 1:2 ratio that's between them because there's a black dot between them. And finally, we have killer index cages, where digits in cages must not repeat and must sum to the total given in the top left corner. In addition, the 3 digits in a cage, X, Y, and Z, when read left to right, or top to bottom, indicate that the cell in row X, column Y, must contain the digit Z. So, for example, as an example, we could have something like 3, 4, and 6. This adds up to 13, and it also says that in row 3, column 4, there must be a 6. So that's an example of how these killer index cages work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, to add up to 24 with 3 unique digits, it must be 7, 8, and 9. To add up to 23 with 3 unique digits, it must be 6, 8, and 9. To add up to 16 without 6, 8, and 9, the most you can have is 4, 5, and 7, which exactly adds up to 16. So this is 4, 5, 7. This is 1, 2, 3 here. Remaining in column 9. 45 minus 24 is 21. 21 minus 13 is 8. So these 3 digits must add up to 8. That means we have 1 through 5 here, 1 through 5 here, and 1 through 5 here. And then this, with one of these being 1, that makes this 2 through 6 here. With 6 with 2 or 5, adding up to 13, or 6 with 3 or 4, adding up to 13. To add up to 6 with 3 unique digits, it must be 1, 2, 3. To add up to 7 with 3 unique digits, it must be 1, 2, 4. Okay. We have a 6, 7, 8, 9 quadruplet in box 3. That eliminates 6, 7, 8, 9 in the rest of the box, so this must be 1 through 5. And 7 has to be one of these 2 digits, which means this can't be 7. 6 has to be one of these 2 digits, which means this can't be 6. Now we have an 8, 9 pair here. Okay. Well... Remaining digits in box 6 cannot have 8 or 9. So they have to be 1 through 7 here. That means we're guaranteed an 8 or a 9 in one of the 2 digits in column 7. Okay. Okay. So these combinations Remaining digits of column 2 are 3, 5, 6, 7, 8, 9. Remaining digits of column 3 are 4 through 9. Obviously, no 8, 9 here, no 8, 9 here. So where's 8, 9? We have a 1, 2, 3, 4 quadruplet in box 4, which eliminates 1, 2, 3, 4 in the rest of the box. So no 3 here, no 4 here. This then must be 5, 6, 7 as a triplet here, because 8 and 9 can't be here because of the 8 and 9 pair in the row. That leaves this as an 8 and 9 pair here. This has to be 4, and this has to be 3, which means this can't be 4, that can't be 3. So this 1, 2 pair eliminates 1 and 2 in the rest of the row. This 5, 6, 7 triplet eliminates 5, 6, and 7 in the rest of row 4, so this must be 1 through 4 here. This cannot be row 4, and then column 1 and 2 being 1 or 2, because we don't have a 1, 2 available in either of these two spots. So then this must be column 4 in row 1 or 2 contains a 1 or 2. Column 4. Can't be row 4, because that would be column 1 or 2, which would be digit here, but because of the 1, 2, 3, 4 quadruplet here, this can't be 1 or 2. So 4 is here, which means these can't be 4. So we're guaranteed a 4 in one of these two digits here, which eliminates 4 in the rest of the box. So it's row 1 or row 2, column 4 must be a 1 or 2 here. We don't know which. If we try to have this be column 3, that's also, we have a 1, 2, 3 triplet in row 5, which eliminates 1, 2, and 3 in the rest of the row. Well, this is 4 or 5 here. This can't be 1, 2, or 3. So this has to be 4, 6, or 8 here to be in a 1 to 2 ratio with this digit. 1 that can't be here. You could have 2, 4, 3, 6, or 4, 8 there. To add up to 8 for these digits, we no longer can have 4, 5 be at the ends, because we have a 4, 5 guaranteed here. So this is 1, 2, and 3, which means 4 and 5 in box 3 has to be in these 2 out of these 3 cells, which eliminates 4 and 5 in the rest of the column. So no 4 here, no 4, 5 here, no 5 here. Where's 4 then in row 4? It must be one of these 3 cells, which means this cannot be a 4 here. So we cannot have 2 there either. Also, if we try to have 3 here as a column, row 1, row 2 must have 1 or 2 there, but it can't be there because of this 1, 2, 3 triplet here. So this cannot be 3 as a column here. Therefore, this must be 3 as a row here. And it can't be 1 or 2 here. So this cannot be row 3, column 2. It must be row 3, column 1, which makes that a 2. That makes that 1, that's 2. So we have row 3, column 1 is a 2. So this is 2. And we have row 2, column 4 is a 1. So this is 1 here. Okay, 2 and 3, eliminate 2 and 3 here, so that's 1. There's no 1 here, no 1 here. This can't be 1 because of 1 in the row. These two digits must add up to 13, which is 14 minus 1. So we have 4 through 9 there also. 1 cannot be here or here. Okay. Something in column 1 is 4 through 9. So if we try to have 4 here, row 4, column 1 would have to be a 9, which is not possible. So this can't be 4, this can't be 9 then. Row 5, column 1 can be an 8. That is possible. Row 6, column 1 has to be a 7, but that's not possible, so this can't be 6, which means this can't be 7 there. Where is 1 in box 1? Can't be here or here because of 1's in the columns. Can't be here because of 1 in the row. And this is filled out, so 1 has to be here. That eliminates 1 in the rest of the row. This becomes a 2-3 pair, which eliminates 2 and 3 in the rest of the box and row. So this becomes a 4-5 pair here. This can't be 3, 4, 5. It's 1. 2 and 3 eliminate 2 and 3 here. So where is the 2 in row 2? Can't be here because of 2 in the box. Can't be here because of the 2-3 pair in the box. Can't be here because this must add up to 14. So it has to be here. So this is 2. That means this can't be 2 there. 1 eliminates 1 here. Where is the 1 in row 4? It can only be here. Okay. Where's 3 in box 2? Cannot be here because of the 2-3 pair in the box, and this can't be because of the cage. So it has to be one of these 3 digits, which eliminates 3 from being there. If we have row 7 here, row 7, column 8 and 9 cannot contain 8 and 9. So this can't be row 7, it must be column 7 here. That eliminates 7 in the rest of the row. This is 12 without 1 or 2 available here. This must then be a 3, 4, 5 triplet, because 3, 4, 5 is the minimum for a non-1 and 2, and that adds up to exactly 12. So this has to be 3, 4, and 5, with obviously no 3 there. That eliminates 3, 4, 5 in the rest of the row. So this is 6, 8, or 9 there. So row 8, so either row 8, column 7 is a 9, or row 9, column 7 is an 8. Okay. Row 6, column 8 and 9 cannot contain an 8 or a 9. So this can't be column 6 or row 6. It must be column 6 has an 8 or a 9. So that means if this is row 8, column 6 has a 9, or row 9, column 6 has an 8. So we're guaranteed one of these is a 9, which eliminates 9 in the rest of the row. That means 9 has to be one of these 2 digits here. And one of these digits is guaranteed to be 8. So we can't have 8 here. So that means where is 8 in this, in box 7? It must be one of these 2 cells. That means these 3 cells must have an 8 and cannot have a 9. Well, actually, that works very well because 8 and 9 would add up to 17. 17 minus 8 is 9, so the remaining digits here must add up to 9. Can't have 1, 8 because we already have an 8 here. So it could be 2, 7, 3, 6, or 4, 5 here. Okay. Where is the 1 in column 8? It has to be here because this must be 1, 2, 5, or 3, 4, adding up to 8 for column 8. This can't be 4. This can't be 4. So to add up to 13, we cannot have 3, 4, and 6 here. It must be 2, 5, and 6, which eliminates 2, 5, 6 in the rest of the column. So this can't be 5, it's 4, this can't be 2, it's 3, which makes this 2. 2 eliminates 2 here, so that's 3. That eliminates 3 in the rest of row 9. That's 3 in the corner. We celebrate because we're getting close to solving this. 6 eliminates 6 here and 6 here. Okay. We have 8 ones. We know where the last one has to be. It has to be there. Twos, we don't have as much information, though. These digits cannot be 5 or 4. So we have 2, no 3, 6, 7, 8, 9 as possibilities. No 2 here because of 2 in the row. Okay. Can we have a 4 here? If we have 4 here, that's saying row 5, column 3 would have to be a 4, and that's not possible. So this cannot be 4 there. Can this be 5? That would say that row 4, column 3 is a 5, and that is possible. Can this be 3 here? Row 4, column 5 cannot be 3, because if this is 4, 5, and 3, then that would be 3. And then we'd have a repeat in that column. Can we have column row 5, column 4? Can that be a 3? And the answer is no. So this can never be 3, which makes this 5, that's 4, and this is 3. So row 4, column 3 has a 5. Row 4, column 3 is a 5. So that's 5. So no 5 here, which means this can't be 8. This 5 eliminates 5 here, so that means this can't be 8 there. Actually, this is an 8-9 pair, which eliminates 8 and 9 in the rest of the row. So this can't be 9. This is 7 and 6. No 6, 7, 8, 9 here. It's 3 and 5. Cannot be 4 because of 4 in the box. So this 3, 5 pair eliminates 3, 5 in the rest of the row. So no 5 here. It's 4 and 5 there. So this cannot be 4 and 5 here. This can't be 7 because of 7 in the box. No 7 here. No 4, 5 here. Okay, no 3 here. No 3 here because of 3 in the column. 6 eliminates 6 here. So this must be in a 1 to 2 ratio. So this must be 8 and 4, which makes this 2, which makes that 3. Therefore, no 3 here. 5 eliminates 5 here. Okay. 8 eliminates 8 here, so that's 9 and 8. So this is saying row 7, column 1 must be a 6. So this is 6, which means this can't be 6. That's 7 and 6. 6 eliminates 6 here, so that's 8 and 9. 8 and 9 eliminate 8 and 9 here, so it's 6. No 6 here. It's 8 and 9 there. So this can't be 6 or 8. This can't be 6 or 9. One of these is a 7. So to add up to 17, this can't be 2, so this can't be 7. No 3. This is 3, 8, and 6, or 5, 8, and 4 here. So 2, 4, 1 should be done. Row 2, column 4 is a 1. 312 is done. Row 3, column 1 is a 2. 716 is done. Row 7, column 1 is a 6. 435 is done. Row 4, column 3 is a 5. Okay. One of these digits is a 5. Remaining digits in row 5 are 5, 6, and 7. So that means one of these two is a 5. Okay, this is saying row 3, column 8 must be a 6, which is not possible. So this must be row 5, column 8. Row 5, column 8 is a 4, which is true. 5 eliminates 5 here, so it's 7. 5 eliminates 5 here, so it's 3, which makes this 5. That leaves this as a 3, 4 pair. This can't be 3 because of 3 in the row, so this is 4. That's 3. 4 can no longer be here. Where is the 4 in column 9? It's here. So 5, 8, and 4 means row 5, column 8 is a 4. Column 4 here. So row 5, column 4 can be 7. It can be. Row 7, column 4, can it be 5? It could be. Actually, no, it can't be. 6 eliminates 6 here, so this is 5, which means these can't be 5. That leaves this as a 7, which makes that 5, so no 5 here. Row 5, column 4 is a 7, so this is 7, which makes that 6, which makes that 5. 6 eliminates 6 here, so it's 2, which makes that 6. No 2 or 6 here, it's 7. That means these can't be 7, this can't be 6. So row 5, column 4 is a 7, so that's satisfied there. Row 2, column 5 is a 6. That's already satisfied. 8 eliminates 8 here. So this must be 2, 9 as a pair. This 2 eliminates 2 from being here, so this is 9, which makes that 2. No 2 here. 9 eliminates 9 here, so that's 8, which makes this 9, which makes that 8. 8 eliminates 8 being there. So this is 9. This cannot be row 8. Column 7 is a 9. So this must be row 9. Column 7 is an 8. Row 9, column 7 must be 8, which makes that 9. That leaves this as 8 and 9 there. Row 8, column 6 is a 9. So those are both satisfied. And the rest, I guess, is just Sudoku. Or normal Sudoku. Okay, we have all the 1s, 2s. We have 8 2s. We know where the last 2 is. It's there. Oops. 3s. We don't have enough information about 3s. 4s, we have 8 4s. The last 4 has to be there. 5, we have 8 5s. The last 5 is there. 6s. In row 9, the 6 has to be there. That gives us 8 6s, so we know where the last 6 is. It's there. 7. In row 1, 7 cannot be here, so 7 has to be there, which gives us 8 7s, so we know where the last 7 is. It's there. 8, we have 8 8s. The last 8 has to be there. 9, we have in row 1, 9 has to be there. In row 6, 9 can't be here because of 9 in the column, so that's 9, which leaves the remaining digits as 3. And that's a solution. Fairly straightforward. Just we're very restrictive depending on what digits could go where, so it made these killer index cages fairly simple to solve. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.